Hello everyone, welcome to our today's session. In our today's session, we are going to discuss that what is meant by NARDL. So basically, NARDL is the extended form of ARDL. So in our previous lecture, as we have already discussed that what is meant by ARDL, so autoregressive distributed lag model, in which we have the lag of both the dependent and independent variables. So in case of NARDL or nonlinear ARDL model, we are dividing our data set into two parts, or we are decomposing the data set. So we want to see the positive effect of a particular independent variable on the dependent variable, and we also want to see the negative impact of any independent variable on the dependent variable. So basically what NARDL does, NARDL divide your data set into two parts, one in negative and one in positive. So moving forward, when to use it. So basically NARDL use to detect hidden asymmetries, it distinction short run versus long run, and it works with both when your data set is stationary at level and when it is stationary at first difference. You cannot apply NARDL when your data set is, or your where any of your variable is stationary at second difference. So the next thing is that, can we apply NARDL both on time series data and panel data? Yes, we can apply NARDL both on time series and panel data as well, depending upon the nature and the requirement of your research, your thesis and your paper. So you can apply NARDL both on time series data and panel data as well. But the thing is that either you are using time series data or panel data, make sure that you have enough observation, uh, or you have enough series of the data set in order to apply NARDL. Because when you apply NARDL, uh, it will subtract number of series, number of the time, depending on that how much lag you are including in your data set. If you are including more lag, so there will be the possibility of more loss of the data set. So the next thing is that what are the preconditions to apply NARDL. So if any of your variable is stationary at second difference, then you are not able to apply the NARDL. Next is decomposable regressor. In your model, you must have any IV for which you are going to decompose it. Second, the third thing is cointegration confirm. We will apply bond test in order to confirm that either there exists a relationship, long run or short run relationship between the IVs or DVs. After confirmation, then we will move forward to the NARDL. Then next thing is for precondition is sufficient sample size. As I mentioned earlier, that either you are applying simple ARDL or NARDL. You can apply it both on time series and panel data. But the thing is that you must have a large number of observation for applying the NARDL model. And appropriate lag selection, it is up to you that how much lag you are going to apply, the lag you are going to apply, or you are going to include lags in your model. And the last thing is that there must be no serial correlation, no heteroscedasticity, and non-normality in residuals. So what are the benefits of using NARDL? It captures asymmetric adjustment, work with mixed integration order or level at first difference, and it gives us the result in single equation model, distinction short run versus long run asymmetry, more realistic policy insights, and nets and linear trend. So this is the theoretical aspect of the NARDL. Now we will move to our EViews environment, and we will see that how to apply the NARDL in EViews. So first of all, we have to bring our data set into EViews. So this is my Excel file, and here I have data set, and I have total of 5 variables. This is exchange rate, OP all prices, IR is the interest rate, INF inflation, and SI is the stock index. And I have data set in the form of month. So I have monthly data. So first of all, I have to copy the data set. So now let's copy the data set. Now we have to go to EViews. So let's delete all the previous work that we have done here. And uh, before moving forward, make sure that you have installed NARDL in your system. So if the NARDL is not installed in your system, you simply go to here add-ins and then go to manage add-ins, and then from this option you can see that here we have NARDL. So you simply click on this and click on add. So this will install ARDL in your system. So as I have already installed ARDL and NARDL in my EViews version, so we will move forward. So after copying the data from Excel, then go to file, new, work file, and here we have to mention that what are the frequency of the my data set. As in my case, my data set is monthly, so I have to select monthly, and then I have to start uh, and end date of my data set. So the start date is January 1st, 2000, and end date is December 1st, 2024. Then press enter. Then go to quick, go to empty group, and then here you can see that you have to simply paste your data set. So now you can see that all of our data set is now present here in EViews environment. So as you can see that range is from 2000 to 2024. The total number of observations are 289. So now first of all, uh, in order to apply an ARDL, we have to apply ARDL. Then we can move forward and we will apply an ARDL. So first of all, we have to select our dependent variable. So in my case, I am selecting or assuming that my dependent variable is exchange rate and the rest are my independent variable. So after selecting all the variable, so in order to make any variable dependent, you have to select first that variable and then press the control button and select the rest of variable. So the rest of variable will become your independent variable. So after selecting all the variables, right click, then go open as equation. So here you can see that ER is coming at first position. So it means this is my dependent variable and these are my independent variable. So now go to this option of method and select ARDL. And from this option I am going to select constant, and then lag selection criteria I am selecting the option of fixed. So it means that I am taking 4 lag of the dependent variable and the 4 lag of each independent variable. So click on OK. So here you can see that it has given us the results of NARDL. So now you can see that these are the results of ARDL, and these are -1, -2, -3, -4. These are the lags, as we have included 4 lags in our model and we fixed it. So it take the 4 lag of the dependent variable and 4 lag of the independent variables. And this simple IR, INF and SI, these are showing the results of the particular variable at current period of time, and the probability values are showing the significance of each variable. So now we have to decompose the particular variables or variable for which we want to see the positive and negative impact of that variable on the dependent variable. So for that we have to go to view, then go to label and type here as vars, and then here you have to enter the variables. You can select one variable and you can also select more than one variable to decompose it. For example, I am taking only one variable, that is OP or oil prices. So now after selecting the variable for decomposition, then go to add-ins and click on here make nonlinear ARDL. So when you click on it, so it will give you the results for nonlinear ARDL. So as you can see that I have selected only one variable for decomposition, that is OP. So it is showing me the result for OP positive. So POS mean positive. So it has taken the 4 lag of OP positive, and here now you can see that it has taken the 4 lag of OP negative. So now you can see that it has given us the result for all prices affect positive and all prices affect negative. And we can see the we can, if we want to see that either they are showing significant result or not, we can check it from here probability values. So now in order to make it better understand, and if we want to see that either there exists a long run relationship between these variables or not, so for that we have to go to view, and we have go to a coefficient diagnostic. So as I am using EViews 13 version, and maybe you are using different versions. So if you are using older version like EViews 11, 12, so when you go on this coefficient diagnostic, here you can see, here you will be see the option of ARDL bound test or co-integrated equation. But as I am using EViews 13, so if someone is using EViews 13, so then there you have to go to ARDL diagnostics. So here you can see that there are option of error correction results, co-integrated relations, and bound test. So if you want to see that either there exists a long run relationship or short run relationship between the variables or not, so in order to check this, go to ARDL bound test. And let me repeat it again. If you are using the older version like EViews 11, 12, and you want to see the error correction term or the bound test, so then you have to go to coefficient diagnostic, and you will see here ARDL bound test results. But if you are using updated version like EViews 13, then you have to go to ARDL diagnostics, and then you go to bound test. So this will give you the result for bound test. So you have to compare F statistic, this value 1.58, with the 5% value of this F statistics. And if this value is less than this value, then it means there is a short run relationship. And if this value is greater than the upper bound value, then it means there is a positive, then there is a long run relationship. So as you can see that my F statistic value is 1.58, which is less than the 5% value of 2.62. So it means that there is a short run relationship. If this was like say 6 or 7, then it will be greater than this value. So it means there will be or there would be a long run relationship. But at the current moment, my this value is less than the 5% value of F statistics. So it means there is a short run relationship. So if your values becomes in between these two values, so then in that case we will conclude that there is no relationship between the IVs and DVs. So in order to check the long run relationship or the short run relationship, we have to follow the bound test. So now go again to ARDL diagnostics and go to co-integrated equations. So this will give you the co-integrated equation. So that is the most important part. So here, and one thing more, if you want to see uh, the error correction result. So here you can see that it will give us the error correction results. So these are the results of error correction. So if you want to include these results in your model, so then go to ARDL diagnostics and co-integrated equation. So this is the our main results that we have to interpret in our thesis, in our paper, or in our research work. So for the significance, we have to see the probability value. If the probability value is less than 0.05, So it means that that particular variable is showing a significant result on the dependent variable. So when you look at all of these variable results, you will see that only oil price negative is showing a significant impact on the dependent variable. Why? Because only this variable probability value is less than 0.05. Other than that, all variables probability value is greater than 0.05. So it means that expect oil price negative, all other variables are showing insignificant impact on the dependent variable. But our discussion is to only understand that how to get and how to interpret the results of NARDL. So this is inflation at lag 1. So when you look at this coefficient value, it is showing a negative impact. So 1 unit increase in inflation will decrease the exchange rate by 1.31 units, and it is insignificant. Why? Because its probability value is greater than 0.05. Similarly, for interest rate, its coefficient is positive. So it means that 1 unit increase in interest rate will increase the exchange rate by 1.85 units. And for oil price positive, it is insignificant because its probability value is greater than 0.05, and 1 unit increase in oil price will decrease the exchange rate by 0.56 unit. And uh, the main thing is, and the technical point is here. Here you can see that oil price negative and its coefficient sign is negative, but we have to interpret it as positive way, because this negative will and this negative will cancel out and it will become positive. So how to interpret it? 1 unit decrease in oil price. Keep in mind, 1 unit decrease, negative mean oil prices are decreasing. 1 unit decrease in oil price will increase the exchange rate by 0.74 units. So I am taking this as positive. So keep in mind, 1 unit decrease in exchange oil price will increase the exchange rate by 0.4 units. So you also can see that oil price positive impact is smaller, in oil price negative impact is greater, as the coefficient value is 0.56 for oil price positive and the coefficient value of oil price negative is 0.74. So it means that exchange rate is more responsive to when oil prices are decreasing rather than when oil prices are increasing in my particular case. So this is how you can obtain and you can interpret the results of ARDL and ARDL model. And the last variable, which is stock index, its coefficient value is also negative. So it means that 1 unit increase in stock index will decrease the exchange rate by 0.009 units, and it is also insignificant. Why? Because its probability value is greater than 0.05. So the next thing is that if you want to see the graphs, so then for that case go to ARDL diagnostics and go to dynamic multiplier graph and select dynamic multiplier, click on OK, and this will give you the graphs. So on the x-axis we have the time horizon and on y-axis we have the values. So this is the graph of inflation, then this is for interest rate, oil prices, and you can see that this is showing the oil price positive effect on exchange rate, this is the oil price negative impact on exchange rate, and this is the stock index effect on exchange rate. And if you simply see the separately each results, you can simply copy this and you can paste it on your research work. So this is how you can apply NARDL into your data set. If you have any query or any question, you can ask me freely.